Hello, welcome back to the lecture series on microeconomics. Now, how can we measure variance of this random variable net present value, and we can see that here this C naught is not a random variable. So, variance of this item will be 0. Now, this is a random variable and that is a random variable. So, the variance will take care of these two cases C1 and C2. We have already found the values V of C1 and V of C2. So, we can directly introduce these numbers to save time. And R value also we are introducing here. Right. So, if that is the expression that gives us around a number approximately this, again in rupees, approximate. After computing the variance of the random variable net present value of the project, let us also compute standard deviation, because it has a different use for risk analysis. So, the standard deviation of net present value comes around 3558. Now, let us look at what use of this standard deviation measure we can make. So, one can compute mu plus minus sigma, and that gives a range of this random variable NPV, net present value. So, if we compute this mu plus sigma, what is the usefulness or interpretation? So, if we assume that the random variable net present value follows a normal distribution, then 66.6% times the actual value or the realized value of NPV will lie in the range mu minus sigma and mu plus sigma. So, now let us look at the values. So, in our particular case, we have a range. If we plug the value of mu and sigma in the expression, this one, we can get 5976, 13092. So, as the lower limit of the range is positive, so as the lower limit is positive, one can purchase the asset or continue with the project. So, with this we are done with our discussion on project appraisal in the case of a risky world. Now, we are going to move to a different dimension of choice under risk, and we are going to see a new concept called expected utility, and we are going to see how a consumer can take a decision on how much insurance coverage to purchase. So, now from illustrations and cases we move to the theory development of consumer behavior under risk. The main question is this: how a person values consumption in one state as compared to the other, and we assume that this will depend on the probability that the state in question actually occur. Okay, so let us start with some notations first. So, we assume C1 equals the consumption in state 1, that is basically outcome 1 of some random phenomenon with probability P1. C2 is basically consumption in state 2 with probability P2, and let us now have a look at the utility function. What is going to be the form of the utility function in this case? How a person values consumption in a particular state with respect to consumption in another state depends on the probability with which these states will occur. The rate at which a consumer is willing to substitute consumption in a state, in a bad state, say when an accident occurs or a natural calamity occurs, for consumption in another state, say a good state where this kind of events do not occur, will definitely depend on the consumer's belief about the likelihood of these events to happen. So, of course, the utility function of the consumer will not only depend on the specific values of consumption in this particular realized states, but also will depend on the probabilities or the likelihoods of these states to occur in reality. So, we can now write down this utility function as functions of the values of consumptions, values of consumption levels in each state, and the probabilities with which the states may occur in reality. Now, we are going to introduce a new concept called expected utility. To model utility in this uncertain world. So, this expected utility is also popularly known as von Neumann Morgenstern utility function after the names of its inventors. So, in this case what happens, as C1 is random, then utility from C1 or the utility in a particular state 1 is also random, and so is C2 and u of C2. So, we have to consider an average utility level, as we do not know which state in reality is going to occur. So, if we have to consider average utility, then in the case of random variable we know that we have to take expectation of the random variable. So, in this case we have expected utility EU, and we can write that as P1 times U of C1 plus P2 U of C2. Now, we are going to make couple of assumptions. Which are critical behind the existence of expected utility function. Assumption number 1 would be, although there can be k possible outcomes, only one of these outcomes is actually going to occur. Number 2, there is independence between different outcomes Number 3 would be the consumption choices a consumer plans to make in one state of nature realized, of course, shall be independent from the consumption choices that he or she plans to make in other states of nature. So, states of nature are basically outcomes. Having stated assumptions behind the existence of expected utility function, let us have a look at the functional form through a graph. So, the expected utility function u is generally defined over wealth level or income level, but as you know, as you do not save in this model, wealth is basically equivalent of consumption. So, we can write that there is some initial wealth level before a state of nature has actually realized, and that is denoted by C naught. Now, there is wealth in state 1 and we can assume that that is a bad state. So, in that case the consumer has C1 units of wealth. Similarly, we can assume wealth in state 2 which is a good state. The wealth of the consumer is C2 and we assume that probability of state 1 to occur or the bad state to occur is P1 and probability of state 2 or good state to occur is P2. And if we assume that there are only 2 states of nature or 2 possible outcomes, we can have this result P1 plus P2 equal to 1. So, let us measure wealth along the horizontal axis and utility along the vertical axis. So, as we are talking about C1 as the consumption level of the consumer in state 1 which is a bad state, it is safe to assume that C2 is greater than C1. So, let us have 2 specific levels of consumption C1 and let us plot C2 over here. Now, we assume a typical utility function concave to origin showing diminishing marginal utility from consumption or wealth. So, now let us find out the implication of expected utility function. So, U of C1 is the consumption level, U of C1 is the utility level from consumption in state 1 which is anyway a random variable, we do not know it a priori. Similarly, U of C2 is the utility level that the consumer derives from consumption in state 2 if state 2 is realized, which is a good state where consumption level is high. So, U C2 is also a random variable. So, when we talk about expected utility, then expected utility could be given as P1 times U of C1 plus P2 times U of C2. So, we are taking an average and this is basically a weighted average where weights are probabilities or likelihoods of each state to happen, and note that as P1 plus P2 is equal to 1, we are talking about a convex combination of U1, we are talking about a convex combination of U of C1 and U of C2. So, basically we can join U of C1 and U of C2, these 2 points on the utility function through a straight line, and we can also measure C bar which is basically the expected value of consumption level, because C1 and C2 are random variables too. So, we can talk about expected value of consumptions also. Right. So, that is basically my C bar. So, for this expected value of wealth or consumption also, the consumer gets some utility from the utility function, and utility out of this average consumption level C bar is given by U of C bar. Now note one interesting thing, this point here denoted by say point A gives that convex combination value expected utility. So, we get EU here. So, what do we observe? We observe that if we assume a conventional utility function, it implies diminishing marginal utility, then utility from the expected value of wealth or consumption is greater than utility averaged over two or more states of nature. If we observe this type of behavior from the consumer, then we say that our consumer is a risk averse individual. There are cases where an individual could be risk neutral and risk lover, but let us not get into those cases. We are going to stick to the more usual type consumer who is basically a risk averse person. So, with this let us stop our discussion for the moment. In the next lecture we are going to continue with that discussion.